Mapping notation. This is like a specific algorithm or formula. I'm going to give you a formula for it that helps you take coordinates that are written in a table and set them up into a new table. So I'm going to use that old one we have. Can we steal this paper here? Yeah, I'm going to steal this one here. We worked on this function a little earlier. So we had f at x was equal to negative 3 x minus 2 squared plus 3. Okay, so we had some function here, and we ended up making a table of it, which was really nice because I don't want to redo that again. We got our little table, and it said our x values and our y values, or represented as f at x. And we had some numbers, negative 1, 0, 1, 2, 3, and we had negative 24. Are these right? Yeah.
Yeah.
Negative 9, 0, 3. So did I write the right ones? Yeah, those are the right ones. Okay, good. So we have that. And I just realized what I've done is the opposite of what I wanted, but it's okay. We'll use it as a check. What we want to talk about first, I kind of jumped ahead. What kind of function is this? So we take a look at it, and hopefully we're able to deduce that actually this is a quadratic function. So the parent function of this, let's call it p at x, give it a different name, is x squared, okay? So the question is, what's the table of that one? Well, that table, I happen to know it, and sometimes teachers will ask you to find key points of a parent function. The key points of this one, they usually work at negative 2, negative 1, 0, 1, 2. And your y values happen to be 4, 1, 0, 1, 4. So here's our values. What has happened is we've taken this parent function and we've transformed it. We use this. So we took this and it became that. But the question is like, how? How did we get those values when we did it? Well, there's some little formulas we can do. We can tactically start plugging away and trying to find them, or we can use something called mapping notation. So we say the x value, so the old x value, sorry, I lied, the new x value. So I put a little subscript to represent new x value is equal to x, the old x value, so we have O, divided by k, and then minus d. And the new y value is equal to a times the old y value plus c. So these two things here are little formulas. I guess I'm going to make green boxes. Here we go. There's one, and there's another. These are two formulas that help you get from here to here. Okay, so this is going to be like our proof of it. Now I don't have a negative 2 here, right? So what's going to happen is I'm going to take this negative 1 and my 1. So I'm going to work on these coordinates as a pair to start. So
why those ones? Why not the first one?
No, we could start with the first one. The reason I chose these is because we kind of have something that represents a negative 1 or a 1 here. When we get across here, I mean, technically it's going to map. I'll start here and then we'll go back to this one. But that's a good question. Why not just start at the top? I could have started at any value. Starting with some easy ones. Ones are usually nice to work with. So this is we'll call this my old x value and my old y value, okay? And we're trying to get a new x value and a new y value after it's gone through all the transformations. So we take this formula. We'll start with this one. So the new x value is equal to the old, so this is this formula here, the old x value, which happens to be negative 1, okay, divided by k. We haven't done this yet. What is a and k and d and c in this one? So we got to talk about the general formula for transformations. We'll call it t at x, maybe for transformations. And it looks something like this. Actually, I'll use an f because yours is going to use f's just to make it simpler. I shouldn't call it f because I've already defined something as f here, but we're going to do it just so it makes sense to you guys. A, and they do something like this. They'll write a big F in here, and then they'll have, I believe, your K. Is that the letter I think you guys use? Yeah. X, subtract, I believe this will be your D.
Yeah.
Awesome. And then outside of your function, it's plus C. Awesome. Okay. So we got to pick that out. That's part of figuring out this formula. I got to know, what is my D, what is my K, what's my A, what's my C? Now this is a quadratic, and it's in vertex form. So we use some pretty similar variables. This happens to be my A, which is going to be helpful for this formula down here.
Yeah.
And this guy out here happens to be my C. That works out really nice. My D value is actually just that too, but
Positive.
K, turns out we don't have one in this one.
Mm-hmm.
There is no K. Now the assumption is if you don't have a K, your K is equal to 1. So in this function here, we're going to say K equals 1, okay? And D, what is your D equal to here?
Might do 2.
Yeah, positive 2. Keep that in mind. That
Yeah,
negative part of
switch
that.
it, yeah.
So that's really important for what we're doing here. And then the other two are a little more straightforward. A happens to be negative 3, and C happens to be positive 3. Okay, good. So now that we have these 4 things, we can use them to input into this mapping notation. We'll go down here. Can I see them? Yeah, I can. Okay, so remember this formula. We jumped back. This was our old x value, so we're dividing by k. K happens to be 1. That makes it really easy to divide by. And then we're going to subtract by whatever my d value was. Happens to be 2. So put it in color. There we go. So if I go down just a little, my new x value is going to be negative 1 divided by 1 is just negative 1. So negative 1 minus 2 becomes our negative 3 here. We have a negative 3 as a coordinate. Our new x value. I didn't happen to write a negative 3 in here, but that's okay. What we do then is our y value. We put it through this formula. Same idea. The new y value is equal to, well, what was our a? We're going to put it in here. Negative 3. Our old y value, which happens to be 1. And our c value happens to be positive 3, I believe, right?
Yeah.
There we go. And we end up with negative 3 plus 3. Turns out it is 0. Here we go. We have 0 in this case. So we take a look and make an error here. It should have got me to 3 and 0, I believe. X value, K value was a negative. No. I think we're okay. I wanted a value that got me the right numbers. So the reason I'm looking this over here, looking at it, is because I have this nice coordinate here.
Yeah.
Okay. And it looks like I've got a coordinate of 0, which is great for my y, but my x1 seems to be off a little. Should have been, I believe, a positive 3 when I did it. Did I put a value in that was incorrect? I don't think I did. So what I'm going to do, just going to check ourselves here, because we did kind of do this in reverse order. I'm going to map. Okay, we were right. I apologize. My error here is in this. This should be plus. Okay, this should be plus because then when we do this plus, okay.
Oh, it'll be 1 and 0.
And that's what my problem is. I was thinking the wrong one, and it maps to that one, which
Yeah.
works out perfectly.
Yeah,
so there it is. We deduced it, and then I was aiming at the wrong idea there. So there we go. So here, this was my whole error. I apologize. I wrote that. It should have been a plus. So these two formulas work. And then what you would do after that, and I'll trim this so the video so it's not so long in that. But you would take the next two. You'd plug 0 in, put it through this formula, and you'll have a new pair. Take these two, put them in the form. A bit tedious. It takes a bit of time, but it'll always get you those values for transformations, okay?
Oh,